Question 9 asks us to complete the square for this function here, 3x squared plus 24x plus 76, for the purposes of putting the function in vertex form. And the first step in completing the square is to factor the leading coefficient, which is 3 in this case, out of the two variable terms. Well, 3 divided by 3 is 1, so 3 comes out here. Is equal to 1 is the coefficient here. 24 divided by 3 is 8, so that leaves 8x here. And we have parentheses around the variable terms. And then we will add something here to create the square. And that something is always going to be the coefficient of the linear term, the 8 in this case, divided by 2 and multiplied by a half and then squared. Well, 8 divided by 2 is 4, and 4 squared is 16. So we add 16 inside the parentheses, but we have to subtract that back out to balance the function. And that's actually 3 times 16 that we added. It's not 16, it's 3 times 16. So that's what we subtract out. Negative 3 times 16 is negative 48. And negative 48 and 76 is 28. The square here consists of x and whatever you got here when you divided the coefficient of the linear term by 2. That was just 4. To check this, you can square x times 4 is 4x, x times 4 again is 4x. You add those two together, you get 8x, and 4 times 4 is 16. Okay, question 10 is a piecewise function to graph. Question 11 is a piecewise function to evaluate. And in question 10 you have 3 functions here, and this is what I was talking about in the excuse me, in class review, is that you should possibly, one approach is to sketch all 3 of the graphs and then erase the portions that don't get used here. So the absolute value function is just a v, and it's translated 2 units to the right, 2 units to the right, and so that's what this is here, absolute value. And then the next function is the constant function. I've only shown the sketch of this short portion, but you could sketch a longer portion if you wanted. And then the last one is the one that really it's best to graph the function as shown, sketch the graph of the function as shown, to make sure that you're putting this all in the right spots. So we see it here as written as 4 minus x, but if we were asked to graph a linear function, we would normally see this as y equals negative x plus 4. Negative x tells you that the slope is 1 and it's negative, so you start at the y-intercept of 4 and you go down 1 over 1, down 1 over 1, down 1 over 1 to the other points of the function, and you draw a line through that. So that's this dashed line right here. If we were asked to sketch a graph of that function alone, we would have some of the line over here, but we don't need it. What we really needed to know was, starting from the intercept, where's that straight line, so that we can then sketch it and erase the portions of the other functions that are not being used. Well, the first function is defined from all the way up until 0 for any x less than 0. So that's where we stop. We stop at x equals 0, which is the y-axis. So we erase all this. And then the constant function is only used from 0 to 2. And so we would erase, if we had the constant function sketched over here, we would erase here, and we would erase here. And then finally, the 4 minus x is used from 2 until 5. And so we erase everything that is the dashed line. And then because this says x is less than or equal to 5, then we put a filled in point right here, a solid point, to indicate that that is where this function stops. So there's your piecewise function graph. Now to evaluate a piecewise function, in the specific values listed in the question, you come here, not here. You come here to the intervals of the x values and determine which of these functions you'll be using to calculate the value, the function value. Well, the first value is 5. So you look in these three intervals and you see that 5 is between 4 and 6. So that means we use this function to calculate, in this case, the rent paid by someone who is renting an Airbnb with this rate structure. So you put a 5 in for the x here. So 90 times 5 is 450. We add the 30. 450 plus 30 is 480. And for 9 nights, you see that 9 is greater than 6. So we use this function here, 80x plus 90. Yeah, you put a 9 in for the x here. 80 times 9 is 720. And you add 90 and you have an 810. So that's the rent paid for some of those stays. 9 nights. Number 12 is a quadratic application. And part A asks, what is the maximum height of the projectile? Well, this is the k value of the vertex. So we need the h first so that we can substitute that in to the function and evaluate it to get the k. And in the ax squared plus bx plus c, this is our a and this is our b. This is our a and this is our b. And so we substitute those into the vertex formula, the easiest way to get the vertex for this function. So b is 19.6, that's the numerator. A is -4.9, that goes in right here. Double that, and that's 9.8. So 19.6 over 9.8, and the fact that this was negative, and we have a negative here, those cancel, those negative ones cancel multiplicatively and give us a positive. And conveniently, when we divide 19.6 by 9.8, we get 2. So that's an easy number to evaluate this function for. 2 squared is 4. 4 times -4.9 is -9.6. 2 times 19.6 is 39.2. And when you add all these three values up, you get 78.4 as the k value, which is the projectile's maximum height. Now, when does the projectile hit the ground is the question in part B, and that's going to be the positive solution to this function set equal to 0. When the height is 0, obviously, is when it hits the ground. And so you set the function equal to 0, and once again, very conveniently, you factor out -4.9, and what's left is a very easily factorable trinomial t squared minus 4t minus 12 factors as t plus 2 times t minus 6. That tells us that t equals negative 2 and t equals positive 6 are the two solutions. T equals negative 2 represents a time 2 seconds in the past. So 6 is the obvious answer. 6 seconds after the projectile is launched is the time at which it hits the ground. And finally, we are sketching a quadratic in question 13. And so we can use the vertex formula or completing the square to determine what the vertex is. Remember, we're looking for 5 points: the x-intercepts, the vertex, the y-intercept, that's 4, and then the y-intercept's sort of mirror point on the opposite side of the axis of symmetry. Excuse me. So the coefficient of the linear term, the quadratic term here is 1. A is equal to 1. Coefficient of the linear term is negative 3. So A is 1, B is negative 3. And so we substitute those values into our vertex formula, which is B over 2A, actually negative B over 2A. And that simplifies to 3 over 2. So 3 over 2 is the x value of the vertex. We substitute that into the function to find the y value of the vertex, which is our k. And so that's 3 halves here. Remember, wherever you've got an x, please set parentheses, and inside those parentheses, insert the value that you're evaluating the function at. And so that's 3 halves here, squared. 2 squared is 9, 2 squared is 4, so this is negative 4. And negative 3 times 3 halves is negative 9 halves. And I gave 10 a denominator of 4, so 10 is 40 fourths. And to give these 3 terms these 3 fractions a common denominator, multiply the numerator and denominator by 2 here, so we have 18 over 4. So this is 9 fourths minus 18 fourths minus 40 fourths. Add all those together, we get negative 49 fourths. So our vertex is 3 halves and negative 49 fourths. And we factor the function to find that its zeros, or x-intercepts, are x equals negative 2 and x equals 5. Negative 2 plus 2 is 0, 0 times anything is 0. 5 minus 5 is 0, 0 times anything is 0, so those are our 2 x-intercepts. To find the y-intercept, we just need to look right here at the constant term. So our y-intercept is negative 10. Here I've evaluated the function at 0, but all you really need to do is just look at the constant term. So the y-intercept is 0, negative 10. The domain, which I think was requested in the function, is all real numbers. Always all real numbers for any polynomial, and a quadratic function is a polynomial. Alright, and so here's the vertex, negative 49, 3 halves for x, negative 49 fourths, which is negative 12.25. And the x-intercepts are negative 2 and 5. Our y-intercept is negative 10. And we have another point reflected across the axis of symmetry here. So there's our 5 points. And remember, the axis of symmetry runs straight through the vertical line through the vertex. And so here's the sketch of the function. And in addition to these functions, there will be inequality, possibly an application similar to the one we had on the one we had in class yesterday. All right, there you go. As always, if you have any questions, email me or text me at 210-464-5781.